Hello. Good morning, everyone. Now we'll start the proceedings of the webinar on driving discoveries through strategic research data management. Good morning, everyone. On behalf of Director InfluMnet Center, Professor Devika Madali, I extend a warm welcome to all the participants and speakers from InfluMnet and Ms. Irax from DataSite. It is great to see many of you are joining us today. Thanks in part for generous support, funding support from DataSite, a global leader in open research data infrastructure. Theme of today's webinar is driving discoveries through strategic research data management, which underscores the critical importance of open and transparent data practices in advancing scientific discovery, innovation, and collaboration. In an era known as for rapid technological advancements and increasing data complexity, the effective management, sharing, and reuse of research data have become imperative. The importance of research data is undeniable, and it's a very foundation for scientific discovery and progress. But for too long, valuable research data has remained in silos, inaccessible and underutilized. In this webinar on open research data management, it aims to change this scenario. The webinar will dwell into the open research data, equipping you with the knowledge and tools to share and understand the potential of open research data management. Whether you are a seasoned researcher or just starting your journey, this webinar is something for you to gain. Throughout this webinar, we will explore various aspects of open research data management, including data sharing policies, metadata standards, make data count, persistent identifier, best practices for data stewardship. In this webinar, my colleague, Mr. Divyakant Waghela, will be talking on research data management. My colleague, Sri Yatrik Patel, will talk on data management plan. Ms. Irax from DataSite will be talking on MEC data count and role of PIDs. And my colleague, Mr. Hitesh Kumar Solanki, will talk on introduction to National Research Data Repository, what we are developing, on which we are working. Now, as to start the proceedings of this, I would request straight away Mr. Divyakant Waghela. My colleague is working as a computer scientist at InfluMnet Center, and he is involved in sole software development activity and data repository and other various activities of the center. So I would request him to start his session. Over to you, Divyakant.
Thanks, Mitesh. Thank you very much. Dear Sir Yatrik Patel, representative from DataSite, Iraxe, and dear distinguished participants, and my fellow colleagues, Mitesh, Hitesh, Dinesh, and Pallab. Good morning to you all. First of all, I'll straight away share my screen because I've been given less time, 20 to 25 minutes. I have to finish my presentation. Hope my screen is visible to you. Anyone or to participate? Anyone?
Yes,
Mitesh or
it's
Dinesh?
visible. It's visible.
Okay.
Yes, it is visible. Please continue.
Thanks you. Thanks a lot. See, this is the second webinar in series. First, we have arranged in conducted in last March. Straight away, I'm moving to my presentation on research data management. I am going to cover this. What is research data? Then types of research data, classification of research data, open data and open science, then Plan S and its 10 principles. What is open research data? What is the benefit of open data? RDM life cycle, RDM. What are the importance? What is the importance of RDM? Verification of research data. What is RDR and its a desirable characteristics? Then there are confusion between IR and DR, institutional repository and data repository. I will be going to cover a few points on that. Then registry of research data repository. Now, first thing, what is research data? In research data management, the first question is what is research data? Now, research data is the data that is collected, observed, created for the purposes of analysis to produce the research results. And there are the various purposes for doing some research work, and it requires different processes to collect the data or create the data, and divided into multiple categories like say tourism data, educational data, environmental data, and each category may require different type of treatments to collect the data or create the data. So now I'm moving to these types of research data. In types of research data, there are basically five types: observational, in which the data is being generated or collected through some observations like sensor data, then collecting data using survey, then neurological images. Then another is experimental data, in which lab experiments are required. Those are data which are reproducible but expensive. As you know that lab experiments require some tools and technologies which is costly, so it requires it is very expensive. Then simulation data. In this simulation data, the data are generated using the models, in which there are some input data, and using input data, the output data will be generated using some models, right? And in this models are very important part, not input and output data, such as climate model and economic models. Just for an example, say by giving some labors and transportation, we need to and the output will be the product. So like that, that data will be generated in simulation. In derived and compiled data, basically the larger set is available somewhere, and from that we need some minor data with few fields and few records. So we are deriving the data from existing source. And another thing is also there: primary data and derived data. The raw data which are available with us, raw collected data, those are called primary, and derived will be like cleaned data sets. Then reference or canonical data, mostly see this is a collection of smaller peer reviewed data sets. It's like chemical structures or gene sequence banks, like that. Now moving to this classification of research data. The research data is classified in multiple things like see methods like experimental, observational, just we discussed about that. Then classification based on formats like say spreadsheets. It can be a database, images or maps or audio files or anything. Then in based on content type, it is numerical, audiovisual, textual or multimedia. Based on nature, it may be analog or digital. Based on sources, it is primary or secondary, and processing raw or processed, as I told you, derived and primary. Now moving to the next point, that is open data and open science. What is open data? Does it mean, see, if the data is available openly, does it mean it is open data? No, it has some characteristic like it should be free to use, it should be reusable and redistributed without any legal, technological or social restrictions. And obviously if it is machine readable, then and then it will be possible. And as I told you, it should be easily accessible. Open open data is benefiting the open science movement in number of ways. Now, what is open science? Open science is refers to the practice of making scientific data, research, and findings accessible to everyone. That's it, without any restriction. In open science, scientific research data and findings will be available to anyone. Now coming to the Plan S. Plan S is an initiative for open access science publishing, which was launched by Coalition S. It is a consortium of national research agencies and funders from 12 European countries, and it was launched in 2018. It requires, see, the scientists and researchers who benefited for or who have been given the fund from the state research organization or institution publish their work in open repository or in the journal which are openly available, in which the data will be available openly, or it should be available by 2021. The main key principle of Plan S is by 2021, all the scholarly publications should be available on open access platform, open access journals, or if anything is not available, then it should be made available on open access repositories without any embargo period. But in this case, the research should be funded by the public or private grants provided by these organizations, institutions, right? This plan S was structured around 10 principles that we will see. In this, author should retain the copyright on the publication, which must be published under open license, that Creative Commons CC BY. The members or the funder should establish robust criteria and requirement for compliant open access journals and platforms. The funder should also provide the incentives for creating the open access journals and platforms if they are not exist, and the publication fees, if their publication fee is being charged by someone, then it should be covered by the funders or say universities, not from the individual researchers. And it should be standardized, formatted, structured, and kept with some limitation. The universities and research institutes
I don't have phones.
should align their strategies and policies.
I'll contact.
See, earlier when they have started, they told that keep research publication should be made available by 2021. But for books and monographs, the timeline may be extended beyond the 2021. Hybrid open access journals are not compliant with the key principle because they are charging for publishing in open. Members of coalition should monitor and sanction non-compliant beneficiaries. Open archives repositories are acknowledged for their importance. Open archives and repositories are acknowledged for their importance. Now in India, we have the same policies like NDSAP. Since 2012, NDSAP is there. It is basically for sharing non-sensitive data which are available in a digital or analog form, which are generated through funds from the government departments, government of India or state departments. And basically it is designed to promote data sharing and enable access to the government of India owned data for national planning, awareness, and future development. Now, what is open research data or say open scientific data? It is a type of open data focused on publishing observation and results of scientific community available for anyone to analyze and reuse. What it will do, it is to allow verification of scientific claim. Somebody has already done research and they have given some decision on based on that. So somebody after that, somebody can use the data, reproduce that result and verify the findings. Then it allows many sources to be integrated. If somebody wants to search on another part and the data is available there on website or on repositories, then they can integrate with the other data which they have generated and they can generate a new knowledge. Now, see, this is about open data, open research data. Now, what is the benefit of open data? So, it will bring the transparency, innovation, then economic growth, accountability. Governments and institutions will be accountable for their actions and decisions. It is used for collaboration between the government, organizations, and individuals. Then open data promotes the transparency by making the information accessible to the public. It is fostering the trust in the institutions. When the data is available openly, it encourages the innovation by enabling individuals to develop new product, services, or solution to the uh, community. Open data is helping in economic growth by creating opportunities for entrepreneurship and driving efficiency in the public and private sectors. It empowers the citizens by giving them tools and informations they need to participate in civic processes. Then researchers and analysts, they can use that open data. They can do the further analysis. Then they can check the trends and generate insights across the fields like healthcare or education or say environment. It is also helping in public service improvements. As I told you, it's like care, education, and all. Now coming to this research data management. Now, what is research data management? It is basically process or practice of organization, documentation, storage, and preservation of the data which are resulted from some research processes. And this data is broadly defined as this outcome of the experiment or observation that validates the research finding, and it can be a number or it can be a qualitative data or say documentation, images, audio, video. RDM is very important part. Research data management is very important and it has life cycle. If the research data is managed properly, then it will give you many advantages, many benefits of it. Now coming to this RDM life cycle part. This RDM life cycle starts from the research question to publication. It includes this choosing a file format, file organization, version control. This anyhow will be covered by Shri Yatrik Patel in next session. So I'm not touching this part, but so straight away I'm moving to this importance of research data management. What are the important, what are the benefits of research data management? Proper data management is fundamental for conducting rigorous, ethical, and impactful research, which is contributing to the advancement of knowledge across various disciplines. And it is essential for several reasons, like as I mentioned, quality assurance. It ensures the accuracy, reliability, and completeness of research data. It is used for reproducibility and transparency by allowing the other researchers to replicating the study and verifying its finding. It enhancing the credibility and trustworthiness. It is for compliance and ethical consideration, uh, for complying with the legal and institutional requirement. It is also helpful in efficient data retrieval and analysis. Organized and properly documented data are easier to find, access, and analyze the data, which saves the time and resources for the to the researchers, which help us to generate the knowledge within time or before the time, we can say. Then data security and protection. If the data is managed properly, it will safeguard the sensitive information from unauthorized access, loss or corruption of data, reducing the risk of data breaches. It also facilitates the collaboration. Properly managed data will help in sharing and collaborating among the research teams. Then it is also helpful for long-term preservation of data. As you know that the research requires some effort, it requires some money, cost. So by spending so much money, by spending so much time, if the research data is not preserved for long term, it is not helpful to the community. Should be preserved for long term. Now coming to this verification of research data. Now, verification is what? Verification, it is a process of making research data findable. F is findable, is accessible, interoperable, and reusable. This concept has gained prominence in scientific community to improve the efficiency and effectiveness of research data management and sharing. Now, what is findable? The data should be easy to find for both humans and computers. If DOI is given, DOI is assigned to that data set, then it will be easier for citing the data set or for finding the data set, right? Then A is for accessibility. Data should be easily accessible once it is found. See, this doesn't mean it should be in open access, but it should have some authentication mechanism. It may have authentication mechanism, right? And it should be accessible if it is available, if we found the data. Then interoperable means the data should be in such a way that it should be integrated with other sources, and it can be in after integration it can be analyzed and we can check the we can find the new knowledge. Then reusability. Data should be easy to reuse for future research purposes. This is related to the licensing information. It should have such license that it can be reused and redistributed without any restrictions, right? Now coming to research data repository. RDR, it is basically data library or data archive, unified data management platform where you can store and manage your data from disparate sources. The data basically used for sharing and analysis and reporting purposes. And RDR should have some characteristics which we are going to see. The organizational infrastructure, which includes free and easy access, clear use guidance. It means the data should be in open access, and data and metadata both are accessible without any charge in timely manner after submitting on the repository. Then it should have proper documentation describing the terms for the dataset access, use, and on policies on data retention, risk management for confidentiality, and monitoring requirements for sensitive data. It should have a plan, and see, repository has a plan for long-term preservation of data. Then under this digital object management, it should support that unique persistent identifier. So the data repository should make the data set accessible and citable by assigning the unique persistent identifier such as DOI, digital object identifier. Then the repository ensures the metadata of the data sets, which is used for discovery, reuse, and citation purpose. The repository provides the expert curation and quality assurance to improve accuracy, and should support common formats. Basically, common formats means what? Non-proprietary. It is better to have a non-proprietary format to export the data and accessible the data and download in non-proprietary format. Should have a mechanism for chain of custody and version control. Under the technology, the authentication mechanism should be there for the data submitter, researcher. And then repository has a long-term sustainability plan, and it should have features for cyber security, like say preventing unauthorized access, modification, and release of data breaches. Such levels of security should be there to for sensitivity of the data. Now, as I told you, I will brief you about this IR and DR. What is IR and DR? So basically, institutional repository refers to the intellectual output of such as intellectual output such as article, thesis, dissertation, conference papers, and other material. It is used. IR is used to host such kind of intellectual output, which are generated from institutes, faculty, faculty members, students, and staff members. Whereas in data repository, it focuses on the data storing and sharing part. It provides a platform for researchers to deposit their data, discover and access datasets related to various disciplines. For IR and ER, the software, different softwares are used. Suppose if you want to create IR, then DSpace, ePrints, Fedora, Hydra, Drupal are used for creating institutional repository. Whereas for research data repository, Sican, Decan, NADA, and Dataverse are being used. So in a nutshell, why the RDR is important for data preservation, data sharing, for complying with the funder, then for providing citation and recognition, data management, discovery, data security, and privacy. There are many types of repositories are available. One, see, we can say general purpose repository where you can host data in unstructured way. You can directly copy and paste your data on this Figshare, Zenodo, or Drive. Whereas there are data specific repositories such as ICSSR data services. It is for social science data service repository. UK data service, then ICPSR, Inter-University Consortium for Political and Social Research. So there are various repositories are available. Now you might have a question that how can we find a repository for our domain? So there is a solution here on RE3 data repository, that registry of research data repository. You can visit this website. It is open science tool. There you can find the research data repository available across the globe. You can go to that repository, you can search for your discipline or domain, and then you can find it has 3000 plus research data repository. It is working since 10 years. And see, DataCite is also a partner of this RE3 data.org. And now this ends my presentation. Thanks a lot. Now I'm over to Mitesh Kumar Pandya.
Thank you, Vivekant, for sharing insights on research data management. Now, I would request my colleague, Mr. Yatrik Patel, to deliver his session on data management plan. Shri Yatrik Patel is working as a scientist computer science, and he is heading the division of SOL development and other software development related activities. He is also one of the pioneer in developing National Research Data Repository. So I would request him to start the session by sharing his presentation. Over to you.
Thank you, Dr. Mitesh. Yatrik here. Good morning to all of you, my colleagues, representative from DataCite, as well as my dear participants. I will be a little quick due to the time issue. So basically, I hope am I audible and visible, right? Mitesh?
Yes.
Yes, sir.
Yes. Please.
Yeah. Great. So my today's coverage will be the data management plan and data access policy. So what I will be doing, I will be covering like what is data management plan, what are the benefits of data management plan. I will talk something on, I will give you a little idea on this research data lifecycle, as well as we'll discuss key elements of data management plan. We will also see certain DMP tools. We will talk about data access policy and its key element along with example. And I have been told that I have to finish in 20 minutes. So, well, I will try to keep the time. So basically, theoretically speaking, data management plan is a formal document which outlines how the data will be handled throughout the life cycle of research project. So basically we know like the data is basically generated during your research starting from initiation to end. And this data management plan describes how the data will be collected, how it will be organized, how it will be stored, shared, and preserved. So, coming to the benefits, like why one should have data management plan. So the first one is the funder mandate. Nowadays many funding agency requires that the researcher should submit his or her data management plan as part of their grant proposal. And this is because of importance of good data management, as well as the maximize the impact and sustainability of research outcome. The second one is transparent and reproducibility. So basically, your research become transparent as your data is accessible and understandable to all other researchers. It also facilitates reproducibility of research finding, so others can verify and build upon this already existing work if data is made available to them. The third one is data sharing and reuse. So basically, DMP should include the how your data will be shared, and this can accelerate scientific progress by enabling others to use and build upon existing data. Further, the research output is basically a valuable scholarly asset, so that should be preserved for long term. So DMP typically includes the strategy for preserving the data beyond the duration of research period. So even if your research is over, your data will be intact, preserved, and available for longer time. The fifth one is compliance and regulations. So data management plan help researcher to comply with legal and regulatory requirement related to data management. This also addresses issues like data protection law, IPR, and funder policy. And this is like quite important for ethical and responsible research. Further, the most important aspect, according to me, is it also addresses the issue of data security and confidentiality. It defines your backup measure, how data will be stored, in which format data will be stored, like what to do in case of data breach, etc. And obviously, it is basically cost efficient and give efficiency to your data. So basically, it can save time and resourcing by reducing the need to recollect or reprocess the data. It also improves the data quality and streamline workflow. Now, as told by Divek, let us go through the research data lifecycle. That is basically RDL. It is the key concept or primary concept in research data management. Basically, RDL is series of the stages where research data goes through before, during, and after research project. So basically, steps involved are starting from creating data. Then once the data is created, it comes to processing of data. After data processing, analyzing. And after analyzing, we have to preserve the raw as well as the secondary data. Then policies to give access and sharing, and then reusing the data. So this is complete research data life cycle. Let us quickly go through each point. So when I say creating data, basically it involves designing of your research, planning for your data management. Further, while research, you will be doing two things, like you will be collecting or locating existing data if it's available somewhere, as well as you will also try to collect the data by means of experiment, observations, measure, simulate, survey, etc. And along with data, you will also plan to capture and create the metadata. As well as while collecting data, you will also plan the consent for sharing. Like if it is a survey form, there might be a disclaimer that, okay, the data collected will be used for some purpose or whatsoever. So this one is the first step. The second step, so once the data is collected, we normally process the data. So that is basically entering the data or digitizing, transcribing or translating the data. Once it has been done, like you will check and validate. You will anonymize certain fields like due to compliance of this data protection law and other laws, like you will hide or camouflage the personal information. You will describe the data as well as manage and store the data. So this comes under processing of data. Once the data has been processed, collected, you will start your actual, producing your actual research outcomes by means of interpreting and deriving data from raw data. This will, once the research output has been produced, you will do certain publication, as well as at this stage only, you will prepare your data for preservation. So preserving means migrating data to best suitable format, as well as migrating data to best suitable medium. Just assume a scenario like if I have conducted a survey in 1998, and that time CD drives were not available. I have collected my data in floppies. So that needs to be converted into some format, then and then only I can sustain. So this kind of things should be considered, like how you will preserve the data. So basically it is backupping and storing the data, creating metadata and documentation, as well as archival process. So once you have created, you have processed, you have analyzed, you have preserved, now it is time to give access to data. So here we will define the policies, like how to distribute, how to share, whom to share, how it will get shared, how the access will be controlled, what sort of copyright, it may be Creative Commons or something else. All should be described on, conceptualized at this stage, along with promotion of data. And then it comes the time for reusing the data. So that is follow-up research, new research, undertake research reviews, scrutinize findings, as well as teach and learn. So basically, this entire thing, that is creating, processing, analyzing, preserving, giving access and reusing the data, becomes a part of entire research data lifecycle. Your data management plan should contain this 7 basic elements. That is, the first one is planning and design. So that is preparing a data management plan, along with identifying the research objective and data requirement, including appropriate data collection methods. Then this data collection also include different method of data collection, ensuring data quality and validity. Then third one is data organization and documentation, which include creation of data management system, organizing and storing research data effectively. Metadata and data documentation best practices should be also part of this. And then data analysis. Here, like data management plan should contain different data analysis techniques, like whether it should be qualitative or quantitative, and which tools can be used to analyze the data. And then the fifth point is data sharing and publication. So basically ethical and legal consideration in data sharing, by means of choosing appropriate data repository comes into the picture. Then data preservation and archiving. This includes the long-term data preservation strategies, data archiving standards and practices, and all this by like ensuring data availability and accessibility. And lastly, data use and repurpose. So basically, this 7 core things should be part of your data management plan, along with compliance, legal, compliance to legal issues, copyright issues and all, and roles and responsibilities, like who will do what. So basically, with each and every research, a data management plan should be available. Now, this looks confusing, like whether we should do research or whether we should spend our time in creating data management plan. But don't worry. What we have is, my screen is, yeah. What we have is there are certain online tools which helps you to create a data management plan. Like there are at present, what I can suggest is there are 3 important online tools which are available. That is DMP Online, DMP Tool, and one is from service.dirisa.ac.za. So let us quickly have one brief demo of DMP tool. See, here I have already logged in. I have already logged in to DMP tool by my
Sorry for
credential.
interruption. Please
Yes.
share your screen. Yeah, now it is visible.
Visible?
Now it is visible. Please go ahead.
Okay. Okay. So here you can see on my dashboard, I can see a test project, right? So if I click on the same, here I have to fill my project details, that is title of the project, abstract, and research domain, start date, end date. Then collaborators, like who will be collaborating with my project. And then most important aspect is here, that is write plan. Now you see everything has been categorized and like methodologically given. Like suppose if I want to write something about data collection, I have to just click it and then say what data will you collect or create. Similarly, how the data will be collected and created. Then once these things are filled in, then documentation and metadata. So here I have to write what documentation will accompany data. And like that, we have ethical and legal compliance, storage and backup plan, selection and preservation, data sharing, responsibility and resources. Everything is available. So what I have to do, just I have to write like as the fields are in given, and as output, what do I get? As output, I will get this is the one plan which I have downloaded from DMP tool. So you can see I can have entire data management plan like DMP ID, title, creator, affiliation, template, project abstract, like what are the data types, what are the related tools, what are the standard, everything will be organized and presented to you. So don't worry about data management plan, just use any of these tools and you will be good to go. So this was about data management plan. Now very quickly, let us go through data access policy. There is a difference between data management plan and data access policy. Data management plan is for particular research, right? Or for a particular research project. Whereas data access policy is an organization-wide things. Basically, it is a set of rules or guidelines that dictates how the data will be accessed, used, and shared within an organization or among the authorized party. It may be a closed group or it may be an open group or it may be open to everyone. So basically data access policy is an organization-wide policy which defines the procedures and controls necessary to ensure that the sensitive and confidential information is appropriately handled and protected. So what should be part of data access policy? Let us quickly go through the key components. The first and foremost one is access control. It specifies who will have access to a certain type of data and under what circumstances. Like it can involve user authentication or role-based access control and other mechanism for access control. Then the second thing is data classification. So here the data is being classified according to sensitivity or like category, whether it is meant for close access, whether it is internal or whether it is public, etc. So that we can have proper access control mechanism based on the category of the data. Then we have authentication and authorization mechanism. This basically outlines the procedure for verifying the identity of the users and determining the level of access to data. Like if a data has been categorized as closed access or internal access, so only internal user should get access to data, complete data, full data, whereas the public should get only access to metadata. So all these kind of mechanisms you can mention or can be part of your data access policy. Further, you also need to specify your policies for data sharing and transfer. So basically how data will be shared or transferred between users or department or external parties. This also includes the protocol as well as data sharing agreement. Moreover, your data access policy should also contain the data usage policy. So that is basically acceptable use of data within the organization, including restriction of copying, modifying, or distributing data without proper authorization or with proper authorization. Further, your DAP should also have inclusion on how the access will be monitored as well as how it will get audited. So this can involve logging access events, conducting regular security assessments and investigations of that suspicious activity. So you can ensure confidentiality and integrity of the data, and not last and least, but important factor is training and awareness. So you have to educate the researcher regarding their responsibilities, regarding data access, regarding security, and this may also involve providing training on data handling procedures, security based practices, etc. So if you like to see one data access plan, data access policy, what we have done is we have done for ICSSR data service. Now here you can see, I will show you this topic, like a basic data access policy guideline. What does it contains? The data acquisition, this will show you, or this will specify what is the scope of language, what kind of research data you are going to take care, then metadata, then data submission, condition for withdrawal of data, data access, coverage of like access to data set, what are the registration, what are the reuse policies, etc. So this entire thing is available on our website, so you can see a little later on. So with this, I end my presentation. Over to you, Dr. Mitesh.
Thank you, sir, for sticking to the time. Now I would request Ms. Irex from data side to present her ideas on make data count and PIDs. Over to you, Ms. Irex.
Yeah, hello, good morning, afternoon. Thank you, Mitesh and InFlipNet for the opportunity to be here. I'm just going to put the slides in presentation mode, and hopefully you can see this correctly. Yes. Fantastic. For this part of my talk, I was going to give a brief introduction to PIDs, persistent identifiers. There's been different references to this in other talks, but also I wanted to introduce you to Make Data Count, what's our work as an initiative, and also essentially give you a bit of an overview of how persistent identifiers support not only the visibility of open data, very important, of course, but also help us then evaluate the reach and impact of the data that is shared openly. So I wanted to first start briefly with an introduction into persistent identifiers. Persistent identifiers, these are unique alphanumeric strings that uniquely refer to a digital resource or an entity. And you can see there on the slide the format that they take. Essentially, what they do, and one of the key elements of persistent identifiers, apart from being able to disambiguate resources, because again, they are unique, is that they come with a set of metadata that provide a representation for that resource. The metadata aspect is important, and I'm going to be coming back to that, because it helps provide the representation of the object. Metadata allows you to make updates, for example. So if the persistent identifier points to a URL, it is possible to update that URL over time if it changes. It's a way of addressing this rotten links problem that sometimes crops up. But importantly as well, the metadata is the part that assigns this persistent characteristic to the PIDs, because it means that if at one point the resource that the PID is pointing to were to be removed, the metadata would remain. So it is always possible to refer back to it and understand that there was a resource there and what the resource contains. So this is the part that assigns that persistency to these identifiers, and what makes them useful, for example, for citing purposes. It is always possible to trace that source. In the context of research data, I'm going to be talking about persistent identifiers, specifically DOIs, but I wanted to mention that there are persistent identifiers also for people and for places. And very briefly, in terms of persistent identifiers for people, the most commonly used that you may be familiar with is the ORCID ID. There are others, but I would say this is the most commonly used by researchers. There is also persistent identifiers for places, so for research institutions, funders, etc. We at DataCite are part of the organizations that support the ROR, which is an identifier again for institutions. And then when we think about things, so research outputs, resources, data, as we are speaking today, persistent identifiers, again, at DataCite will work with DOIs, digital object identifiers, but there are also other persistent identifiers that are used by different groups and communities, including IGSN, ARC, and others. So I just want to give you a brief example as to what this looks like in practice. For ORCIDs, for example, you can see here my ORCID profile. ORCID provides the opportunity of creating a public record for the researcher. You can add a little bit about you and your activities, so a short bio. But I think, and the other thing I will mention is that ORCID gives you the opportunity of choosing how much data you make public versus keeping private. I think that one of the key characteristics and features that I very much like from ORCID is the fact that they integrate with other platforms, and it is very easy to actually update your outputs, the works that you are producing, and have that up to date on your ORCID profile, because they will integrate with journals, with Crossref, to in automated ways add that information to your ORCID profile. So you see there, for example, for me, I have a number of reports and preprints on my ORCID profile. All of that has been added automatically through the repositories and Crossref metadata. Coming back to the persistent identifiers for research organizations, just as an example, This is the raw record for InflipNet. It provides information publicly available, again, about the organization type, location, and some other characteristics. And then when we are thinking about research objects, so articles, preprints, reports, but importantly, research data, of course, the DOIs are one of the persistent identifiers for those objects. And as you can see, this is an example from a data set published at the repository Dryad. It assigns a DOI to that record, and this importantly gets added into the template for citation, so that this can be then incorporated into those citations to give credit to this data. Right, so I also wanted to talk to you briefly about DataCite as an organization. We are a global community. We work with over 3,000 repositories across the globe. We have a mission to make sure that research outputs and resources are openly available, but importantly also connected across the ecosystem to facilitate the reuse and in turn advance knowledge across disciplines. Our activities focus on providing tools and services that help the community create and manage persistent identifiers. And again, importantly, because we have this mission to connect outputs, to integrate these services so we facilitate the discovery and reuse of these different objects and resources. We are a nonprofit organization. We have been in operation for 15 years and currently host over 55 million DOIs, again, for a variety of outputs. DataCite originally was created around making sure that there were persistent identifiers and visibility for data sets, but I want to emphasize the fact that we have expanded over time and we have a DataCite metadata schema that provides our members and repositories the opportunity to mint DOIs for a wide range of research outputs. You can see them listed there. I think we are almost at 20 or more than that by now. So it is possible to assign DataCite DOIs for obviously data sets and collections of data sets and any aspect associated with them, like, for example, data management plans, as we were just hearing from the previous speaker. But something I will highlight is that we are also a great service to provide DOIs for items that are currently or have been considered part of the grey literature, theses, dissertations, preprints, etc. So, a wide and diverse range of outputs for which the institutional repository is the primary publication point. I also wanted to highlight the importance of persistent identifiers in making research data fair. An earlier speaker has provided a nice overview of the FAIR principles. Essentially, what the FAIR principles aim to say is that having data accessible is not enough. There are a number of other characteristics and attributes that we need to work on providing for those data sets so that they really their use is maximized by the community and their value is maximized for the community. Again, the FAIR principles are about making research data findable, accessible, interoperable, and reusable. The findable aspect is very much associated with having this globally unique and persistent identifier. But I would say the four of the principles are really pretty much underlined by having the associated metadata that comes with the persistent identifier that again allows the data set to be retrievable, more easily discoverable, but also interoperable with different platforms. As I was explaining, DataCite has a focus on this connecting of outputs, and importantly, metadata as rich as and as higher quality as possible will really facilitate the reuse of that data set. And I think this provides a nice item to move into the Make Data Count introduction, this reusability of data sets, because this is the key focus of the Make Data Count initiative. Make Data Count is a community initiative, and our mission is to promote the development of responsible metrics for open data. What we want to enable really is to have metrics that will inform responsible evaluation and reward of research data usage and impact. Essentially, we want to get to a place where research data is evaluated and considered as a primary research object. Make Data Count works on different areas of focus. We have been leading and still do so open infrastructure that supports the development of data metrics, but also work closely with community members and different community efforts to co-create standards that can support these practices towards data metrics. Again, working with many in the community, we complete outreach to raise awareness around data metrics and facilitate implementation and adoption of best practices. And importantly, we believe that for metrics to be responsible, they need to be contextualized according to different uses, different community practices, etc. And we have collaborated with bibliometric studies to build that evidence about practices by different groups. I've now mentioned data metrics several times, so I wanted to unpack a little bit what we mean by this. We describe data metrics as meaningful and contextualized quantitative or qualitative measures of how open data sets are accessed or utilized. There are a number of measures of data usage that come under this data metrics umbrella. One of them is data citations that I'm going to be speaking a little bit more about in a moment. So these structure references to data in the same way as we may cite articles, for example. Normalized counts of views and downloads is something that we have also done some work on to feed into data metrics, but there may be other measures of data usage that are collected by repositories and platforms according to the ways that they provide for users to interact with those data sets. I also wanted to spend a bit of time emphasizing why data metrics are important. There's been a lot of focus over the last decade or so in supporting access and accessibility to research data, which is obviously fantastic and we very much support. But we believe that for responsible data stewardship, we need to move beyond access and start evaluating what's happening with those data sets that we've made available. Essentially, gain an understanding as to how open data is being used, in what ways, and by whom, perhaps what data sets are being underutilized. And this is important if we want to make data sharing rewarding for those who produce and share the data, but also to help us make informed decisions across the ecosystems to what are the best practices for open data. So, for example, there are a number of ways in which data citations give us information that feed into these goals. Again, data citations are a way of providing credit to the researchers who produce the data. Data citations increase the transparency and reproducibility of the work that's being shared, because by providing that citation, again, it is possible for others to trace back the data set that underlie the analysis, perhaps in that article, in that report, etc. Importantly, data citations are a way of showcasing the added value on the work, the important work in data publication and preservation that repositories do. And also data citations fit into this collective knowledge of how data is being used and allow us to complete this evaluation of open data as a whole across the ecosystem. I wanted to spend a few moments talking about data citations specifically. There's been quite a bit of work on this as well over the last 10 years or so. A lot of community best practices and resources have been developed to help different stakeholders and community groups adopt data citation practices. This started, I would say, with the data citation principles published in 2014 as part of a 4C11 working group. It was the first time that there was an articulation of the purpose, function, and attributes of data citations and making it clear that we needed citations to data that were readable for humans, but also machine actionable. But there's been, again, a lot of work done across repositories and also working with publishers to try to increase adoption of best practices for data sharing, data citation. I provided a few resources there if you would like to read more. From the aspect of the data side services and the work we do with our members to support, again, the use of persistent identifiers, DOIs for data, and the metadata that comes with it. It's important to highlight that data citations can be included as part of the DOI metadata. This is something that is captured through the metadata schema that provides an opportunity to incorporate information about related identifiers to the data set. So for example, if an article is citing the data set for which you are registering the DOI, it is possible to include that, the information about that citing article in the metadata for the data set, and to create a data citation by utilizing the relevant relationship in the metadata schema that will designate that citation in the direction of the data set is cited. And you can see examples here of how this is represented in the data site metadata. Again, in this example, the relation type is cited by, pointing that there is an article that cites the data set that has that DOI. I also wanted to say that another important aspect of the services that DataCite provides around data citations is that we collect the data citations that are registered through the metadata, but then provide services for the community to also access this information. It's essentially, all of our metadata is CC0. It can be harvested and utilized by the community according to their needs. We provide data citation information in a number of ways through the DataCite APIs, as well as our search portal, DataCite Commons. You see an example here of DataCite Commons, the record for a data set, and it will provide information on citations that are available for that data set. I also wanted to mention that DataCite collaborates with Crossref on a joint service called Event Data that incorporates links between different research outputs. So that's another place where we will include store information about citations to data from that we may have in the DataCite metadata, but Event Data also provides citations to data that may be coming from the publisher metadata that is deposited to Crossref. So again, it's a way of trying to facilitate making those connections between data sets and other outputs. I also wanted to mention briefly a project that we're working on that is focused on data citations. We believe that there is a strong interest in the community in getting access to this information and the value that the metadata provides in enabling finding citations to data. But we also know that this doesn't cover every instance of data sets being used, because in many occasions data sets may be mentioned in articles, for example, in the method section or in the data availability statements rather than the references. So to facilitate having broader access to information across the ecosystem about how data sets are being cited, we are working on building the data citation corpus, a comprehensive corpus where the goal is to incorporate data citations from different sources into a single centralized resource that, again, will be publicly accessible to the community. The idea is to collaborate with other groups who may also be doing work to find data citations and incorporate those together into a single store. In the initial stages, we've done a collaboration with a group to try to identify mentions to data sets in the text of articles, and we have a data file with the pool of citations that we have currently. I'm just going to, I just click the video to make sure that you can view. This is a dashboard that we have created for a high-level view of the citations that we have currently in the current file. It's very early stages, but the goal of the current release of the data citation corpus is to incorporate the data citations that we already have through DOI metadata coming from DataCite and the Event Data service, but also complement that with data citations that have been identified through machine learning. So we collaborated with a group that did text mining of articles to find persistent identifiers to data sets, and they have contributed over 8 million citations to the data citation corpus in that way. I've talked quite a bit about data citations, but I also wanted to mention briefly that we've also been doing quite a bit of work about views and downloads. We have a number of tools and services that enable repositories to capture views and downloads in consistent manners across different repositories. So to mention briefly, there is the Counter Code of Practice for Research Data that allows standardizing the counts across repositories, and DataCite can receive those records and make them available. And to facilitate implementation on this type of reporting, we have also created a usage tracker that collects web-based usage for data sets. And it's a new tool that we are encouraging repositories to implement to try to collect additional information, again, on these views and downloads for the data that you host. And this information, the same way as citations, if repositories submit that to DataCite, we make that available to the community through our usual services. You have an example here through the DataCite Commons portal. Right, so I'm almost at the end. I just wanted to finish briefly with encouraging you to join the DataCite community. DataCite operates on a member model that also gives members the possibility of participating in our governance. A couple of membership models that we have is direct members, an organization that has one or more repositories, and you can join as an organization as a direct member. Otherwise, we also have the consortium model that allows like-minded organizations that are working together in a particular region or in a particular discipline to join in that format. It's an opportunity to, again, participate in DataCite's governance and includes a number of repositories as part of that membership. You have full information about membership options in the DataCite website. And I also wanted to invite you to keep up to date and participate in Make Data Count efforts. We very much welcome participation and feedback on the data citation corpus, so feel free to get in touch with me or complete the form that we have if you would like to hear more. And another great way of keeping up to date is the Make Data Count newsletter, so do sign up if you want to know the latest of what we are working on at Make Data Count. And with that, thank you so much for your attention.
Thank you, Irex. Please stay here if somebody is having question at the end of the session. We will be taking question and answer. So thank you very much for your session. Now I would request my colleague, Mr. Hitesh Kumar Solanki, to present about National Research Data Repository, an InfluNets initiative. Shri Hitesh Kumar Solanki is working as a scientist, computer science at InfluNet Center, and he is one of the core members of NRDR group. And, he has taken a lot of efforts in developing this data repository. I would request Shri Hitesh to take over the session. Hitesh. Screen is visible.
Okay. Am I audible?
Yes, now it is audible.
Okay. Good afternoon to all. Myself, Hitesh. I'm working, as mentioned, I'm working in NRDR group, and just today I'm going to glimpses about NRDR. So how it will be beneficiary to research community in higher education sector in India, as well as mentioned in previous two sessions, what is the role of persistent identifier, as well as how do you manage your research data set, and what is do you have any plan about to preserve the data set which is contributed by faculty member as well as research scholar. So as before archiving or planning research data management, just means how, if you have a plan about the research data to be archived at institute level, and do you have any infrastructure to archive and preserve data set and make it accessible in open access mode for higher education stakeholders, just like research scholar as well as a faculty member. So those institutes do not have a any infrastructure. So we have taken initiative to make a centralized research data repository. Those who have already data repository, they can share metadata at our platform, as well as those do not have, they directly deposit the data set in NRDR. So before accessible to, there would be the two types of stakeholder of this portal. One is institute, as second one is researcher as well as faculty members. So to join as an institute in NRDR, there would be institute should have a data management plan for data preservation, and once finalized the DMP for by institute, and institute can sign MOU with Implement Center, and after that one collection or dataverse, dedicated dataverse would be assigned to particular institute, and under that institute can deposit data set, and once it is deposited in NRDR, it would be accessible by researcher from as a research end user point of view. Once it is deposited, researcher can search and browse their relevant data sets. They can explore the metadata, including study description, data description, variable description, how many variables available in the data sets, how it is collected, which sampling method has been used to collect the data, which region the data is belonging to, which region, along with entire description would be available, and that can be explored by researcher. And after that, it can be finding suitable or appropriate data set for their, based on objective of the research, proposed research, they can access, and after that they can reuse and share to the research community. But apart from this,
ब्रो
there would be, yes,
आवाज
there
ही नहीं आ
would
रहा
be,
यार
am I audible?
जल्दी आना
Yes, you are audible.
Okay. Apart from these features, there would be the on-the-fly data visualization tools would be there, where user can explore the univariate analysis, bivariate analysis on the NRDR portal itself. So there, as I mentioned, there would be the two types of stakeholder. One is the institute, means any one means single point of contact would be assigned by the institute higher authority to communicate with NRDR team and institute, between institute, and second would be the researcher. So, and whatever data set deposited in a NRDR, that would be organized in a collection manner. Just like we are using open source software Dataverse, which is developed by Harvard University, and we have customized as per our Indian research community or Indian context, and under that each and every data set would be grouped in a one collection, just like, and many collection also can be archived in a parent collection. So parent collection is, we can say is a either we can use the term collection or dataverse. So parent dataverse, under parent dataverse, n number of child dataverse can be created, just like one parent dataverse would be treated as an institute dataverse, and n number of department would be treated as a child dataverse under that. And each and every department we can archive or preserve the data sets which is contributed by faculty members or researchers for that particular institute. So such a way means data set would be organized in a particular data sets. So key features of NRDR, National Research Data Repository, for as an institute coordinator or institute administrator. So allotment of parent dataverse would be assigned by NRDR team to the single institute coordinator, and that parent dataverse will have options to customize homepage for your branding, institute logo, about your institute, and many other things can be maintained at homepage of data institute dataverse. Under that you can create n number of sub dataverse, and after that you can submit metadata about the data sets which you would like to deposit in that particular dataverse or a particular instance in a National Research Data Repository. And after that, once it is submitted by metadata for that particular data set. Files would be available either in CSV, TSV, RData, SPSS, or many other files supported by NRDL that would be deposited and that can be made accessible in open access mode for faculty members and scholars across the world. So even there would be the features to access which file or which data set means accessed by researcher and how many it would be downloaded by that research scholars. So that can be also supported. User statistics also would be available for a particular institute in a counter format. So let us tour of NRDR. Once you land on homepage of National Research Data Repository portal, you will, as an institute coordinator or as an administrator from institute side, you will have two options. Either you can create a Dataverse or you can create a data set or deposit a data set. But for that, you required a credential. So we implemented the access mechanism by using the native username and credential base, as well as single sign-on features also implemented. It can be logged in via Google or Kit. Sibboleth-based login means institute login or GitHub repository. That also can be available. So you can sign via that once once you logged in based on your credential, you would have a list of Dataverse would be available in your institute instance, as well as how many data sets would be already uploaded. That list would be available, and we'll have a various publications whether it is published, unpublished, under draft, under review. That all the category you can means it is available. So you can once it is published. So based on provided test credential by DataCite team, we have integrated DOI from DataCite in NRDL. So just this is the screenshot. One DOI has been assigned to particular data sets. So it would be remain persistent for DOI.org, just like with alphanumeric prefix as well as a particular unique number to that particular. So it can be accessed and redirected to particular data set where it is available. So apart from this, you can create a new Dataverse. Once it will ask the brief information about what is your host Dataverse, which name you would like to assign for that new Dataverse. You can assign identifier or just like NRDR 1.implement with a prefix for that. Which type of Dataverse you would like to? It may be institutional, it may be related to researcher, it may be related to journal, such kind of information you can. Affiliation, storage, description about that particular data that can need to be entered for creation. Apart from this, you need to assign metadata fields. Okay, for particular Dataverse, which metadata scheme you would like to opt. So either you may use whatever customized NRDR metadata scheme, or apart from this, it is dedicated based on particular subject, just like astronomy or life science or social science. According to that, you can customize or opt the metadata scheme. Even under that, you can choose particular field also. So this such a way, fully customized interface would be available for you. Even which field you would like to select or choose for browse and search and facet, that also would be available. It would be decided by institute coordinator, and that would be available according to search and filter options would be available on this particular Dataverse, which would be created by institute coordinator. So once it is created under that, you can once it is Dataverse created, you can deposit your data sets. So for that, metadata about that particular data set also would be entered in a particular form. So whatever scheme you adapt for metadata scheme, metadata, that would be according to that form would be opened, just like title, author, and number of author or contributor would be available. And which identifier scheme, just like if you want to assign identifier scheme in ORCID or any other, so that also would be available for that. Apart from this, contact number, description about that data set, which subject you would like to assign for that particular data sets, keywords, related publication, if based on that data set you want to deposit, that also you can mention under or link with this. Just like a Sodhganga, you are going to deposit a thesis, and whatever data sets contributed by that particular research, that can be deposited and it can be linked to the Sodhganga thesis or persistent URL or handle. So it can be linked with dataset along with that thesis. Also, that can be means that provision also available under this portal. So apart from this, once metadata about the data would be entered by institute coordinator, after that you can deposit raw data sets in which will be organized in a different types of format that can be entered under that. So once it is deposited, dataset would be deposited on a research data repository. Now it would be available for researchers in an open access mode. So what are the key features of NRDR for as a researcher? So without login, without any credential, you can just search and browse the relevant data sets from deposited data sets or available make available by institute on this portal. This portal will have a filtering mechanism based on Dataverse category, just like institutional, researcher, journal. Apart from metadata, source, publications, years, author name, subject, keywords, and year and deposit. That can be, you can filter the dataset and find your appropriate dataset based on your research objective. Apart from once you select the dataset, after that you can explore the metadata just like a document description, study description, data description, file description. Everything would be available on a portal. Without login, you can explore the metadata, and even you can view the data set in a spreadsheet viewer as well as data visualization tool, just like Data Explorer or 2 Raven also integrated in a NRDR. And apart from single sign-on mechanism also implemented under this. And as I mentioned earlier, also each and every data set have a unique persistent identifier. Right now we have in a pilot phase, we have integrated data set DOI with the data set. Okay. So once as a researcher you land in a NRDR portal, so as a researcher you can have a search interface. Either you can search based on any keyword or data your description in a search box. Apart from there, it is available categorization of data sets available based on subject category. So directly you can browse from that. Apart from that, recent activity made or done by in any particular Dataverse or other Dataverse, that also highlighted in a home page. So you can directly take a note and find out the recent activity, and you can study about that. Even user statistics in related to number of deposited data set harvested from other repository where only metadata would be available on and original data set would be available on that particular source data repository. Even how many number of files download or deposited, that with last 1 month or all as of now. So that would be available on a home. So this brief glimpses about the statistics would be available on a NRDR homepage, and that can be used. So once as a user, as an end user, or as a faculty or as a researcher, you can find out based on your keyword or subject. Apart from that, you will have a filter option based on publication year, author name, subject, keyword, deposit, and many filter option can be set under that. So you will have a list of data sets which would be available on a NRDR portal. Once if you would like to any one of the data set would like to explore, you just click on that particular title of the data sets. It would be available. It would be available in a detailed form. Once where you will have who would be the coordinator contributors, where it is, what is the title of that DOI, apart from description, which subject assigned for that particular keyword, even how many number of times it is already downloaded, you would like to contact the owner of that, that also can be available under that. Under that, you will have 4 different tabs. Under file tab, you will get a list of data sets or data in a raw format in a multiple number of files. Under that, you can download original file format. Apart from that, various tab delimited R data format or variable metadata description or data citation file, all different kinds of file format can be exported. Apart, as well as you can view online on the same portal in a spreadsheet viewer. Apart from Raven and Data Explorer are 2 analytical tool where you can just on the fly data visualization and various reports you can derive from this. Apart from this, you can have a full citation details about that particular data sets, and whenever you are using that data sets, so you need to means as a ethical principle, you need to cite that data set in your research article or thesis. So you can export the metadata from this based on various types of format, just like Dublin Core, DataCite or JSON, or all the details would be exported in a different format. Apart from this, is there any terms or license you would like to maintain or mention in that particular for a particular data set? That also can be maintained. And there is another features for guestbook, means if you create any guestbook or assign to particular data set, so then before downloading, it will ask brief or preliminary information about user. Once it is added or entered by user, then and then it will be downloaded. So such kinds of information also can be taken by end user. And if you have multiple types of versions in a same data set, so you can maintain the version control also over there, and you can find out the differences between version 2 and 3, and what are the changes in version 2 which is not available in version 2 but it is available in version 3. That can also be make available under this portal. So with brief glimpses about the key features for researcher as well as institute coordinator, I just conclude my session. If you have any query related to, please feel free to ask.
Yeah, thank you, Hitesh, for completing your session on time. Now it's a time for a question answer. So Dinesh, please monitor this. And if somebody is having question, please put it in the chat so that we can ask the question to the presenter. Even you can unmute yourself and ask question directly to the presenter.
Solanki sir, namaskar.
Yeah, please speak aloud.
Namaskar, sir.
This is Dr. Panduranga. Just for your platform, you said you are using one of the software used by MIT. May I know what is that software?
Dataverse. Dataverse.
Dataverse. Oh, okay.
Dataverse is a open source software developed by Harvard University.
Okay, that we can use for as per our customization. No? We can do customization. In
Yes, it can be customized as per our requirement.
Okay, okay, thank you.
Yeah, any other question?
Akanksha, someone is raised the hand. Can you please ask your question?
Dr. Mitesh, I don't think anybody is having question here.
Okay. So no problem. Thank you very much, everybody, for attending this session. I'm very much thankful to all the participants as well as speakers, especially Ms. Irex for joining very early in the morning. So, and I'm very much thankful to Irex and other presenters from my office. And thank you DataSite for providing the support for conducting the webinar. So
Yeah,
now we will be closing this webinar. Thank you very much.
Sir, I have a doubt. Can I ask?
Thank
yeah,
you so
please.
much.
Yeah, please.
Sir, can we get the PPT you are presented to
Yes,
our
you will
mail?
get it.
yes,
Yes,
yes.
you will get it.
Uh,
We'll be
last
sharing it.
It
last
will be
week,
hosted.
we didn't
Yeah,
get
it will be
that.
hosted on our
It will be
institutional
held-
repository.
Huh? Sir,
It will be hosted on our institutional repository and a link will be published very soon. Is that correct, Nitish?
okay, sir.
Yes, yes.
Yes, sir. Thank you so much.
Sir, can I get the recordings
Hello?
in later?
No, we'll be releasing small videos on this. Entire recording will not be shared with anyone.
Hello. Hello.
Hi, sir. Can we get certificate?
Yes, you will get the certificate. We'll be floating a questionnaire after the answers are given in the specified format. We'll be giving you a certificate.
Thank you, sir.
Hello. Hello. Hello,
Yes,
sir.
Pallavi. Yes, Pallavi, please.
Hello, sir. My question is to Hitesh Kumar Solanki, sir. Sir, it is NDRD is subscribed based repository or it is free, sir? To
No,
access?
There would be no any charges or subscription. It would be available for in open access.
Okay. Thank you. Thank you, sir.
Hope I think you clarified all the questions.
சார் அன்னைக்கு மாதிரி ஒரு பேப்பர்ல எழுதி வாங்கிக்கலாமா கூகுள்ல வந்து ரிவ்யூ வாங்கணும் வந்து இது நியூ ட்ரீட்மெண்ட் இருக்குல்ல உங்களுக்கு நீங்க சொன்னீங்கன்னா அதோட உங்களுக்கு எவ்வளவு பயன்பாடா இருந்துச்சு
I think Mitesh, we can close the session now. There is
Yes.
no more questions. Yes, so I'm just ending the meeting.
Yeah, thank you.
Thank you.
Thank you so much for having me. Have a good day.
Thank you.
Thank you.